we are looking at here how we can take inspiration from nature, so different things we see in nature, and then try and make our own man-made versions of these things. So the first, I think the best example we've got actually is this. Does anyone know what this is? A leaf, yeah? Do anyone know the more specific name of the leaf? Pardon? Oh, that's close. I guess it does look similar to one. Where do you think you might find this leaf in the wild? You're right, near some water, on the water. So maybe in the rainforest.
Looks a bit like a lily.
It is, it's probably in the same family as the lily pad. It's a lotus leaf. So these are big leaves that you get and they live on top of the water. So seeing as they live on water, should we have a look at what happens to them when you put water on it? Do you want to have a go? Whoa. Is that what you expected would happen? Have you seen that with the leaf before? We got loads, nice one. Whoa. Sorry. Yeah, so this is really, really water repellent, isn't it? It's amazing. Wouldn't it be really good if all of our tents and all of our coats were made out of such a good material? How are your coats? Are they keeping you dry?
Really?
Okay. Yeah, so this is an example of somewhere where scientists look at something in nature and think, hey, we want to make this for ourselves. How can we make this for ourselves? So if you look at this, is there anything about it that might give you a clue as to why it's so good at being repelling water?
Damp and dry.
Pardon?
Yes, damp and dry.
That's as a result of it being water repellent though, isn't it? What about it? Can you see anything? It just looks like a normal leaf, doesn't it?
It just looks like an old battered leaf.
It does. It's weird that even though it's old and dead, it can still have this property. And that's because it's actually to do with its structure. So you take a microscope and zoom really far in on this, then you have a better understanding of how it works. So can anyone find the microscope image that matches up with the lotus leaf? We've got a few. Well done, you got it. So here's obviously the lotus leaf.
Why is it blue?
Just a bad photo. But then underneath we have some black and white images of a zoomed in version of the lotus leaf. So we've zoomed in so far, more than your eye can even see, even with a magnifying glass like that. We've used microscopes that are bigger than me to zoom in and look at this leaf. So we take a tiny amount of it, put it in the microscope, zoom in, and so we zoom in and we can see it's got this weird structure. We didn't think it would look like this. What about this structure do you think might repel the water?
It's all tight together.
Yeah, it's quite small little bits of it. So we've actually tried to make, using Lego, a demonstration model of what this structure is like. So if this is the leaf here, what do you think this is going to be? Pardon?
Like the water.
Yeah, the water. So this is our water droplet. And as you were saying, they're so tightly packed together, these structures, that the water droplet can't actually get in and make proper contact with the material. It just rolls straight off. So you have bits of air in here as well, and it's all repelling the material. So the water just goes straight off. So it's this kind of, where did the picture go? Here. Is this kind of structure that helps it be water repellent. So can anyone have a shuffle through all the other microscope images and see if you can find any other similar structures to this, any other water repellent structures? That one's a little bit different, we'll get to that in a bit. There's one near me. Yeah. So this one, these are also water repellent materials. They're called hydrophobic materials. But do you think this is man-made or do you think it's made in nature? Where do you think these materials are from? You think they're from nature? What about you?
I think they're man-made.
Okay, you man-made or nature? Man-made? Nature. Do you think this material is man-made or from nature? Nature, okay. So these ones are actually man-made. So I don't think it's a bad guess to say from nature because nature does do similar things, but these are actually the man-made ones that we've grown in the lab to have this similar hydrophobic, water-repellent property. And they work really well as well. But it's quite expensive and time-consuming to make these materials. So we've got to do a lot more research into how we can make them cheaper and better and easier to produce so that we can use them on all types of things like our coats and our tents. So there's a long way to go. You were looking at this one though as well. What's going on in this microscope image? It's a gecko, well done. And what is it that geckos do?
They climb up walls on teeth.
They do exactly, and we can't do that, can we?
They have sticky feet.
Exactly, it's because they have sticky feet.
Is the writing upside down?
It's actually just the gecko's upside down, I think. So you're right, they have sticky feet. So again, scientists try to do these experiments where they zoom really far in on the sticky feet to figure out why they're sticky. So they zoom in further and further and further, and they can find that it's actually the structure on their feet, it's the structure that manages to create the forces that makes the material sticky. So this is a gecko's feet and how it's made sticky. But I want you to have a feel around the different things on the table and see if you can find the man-made sticky object. Yeah, well done, you got it. So when they're wet, it doesn't work so well, and everything's getting wet. So do you want me to dry that for you? There you go. Yeah, almost. Dry off a bit more.
It feels like rubber.
Yeah, it does feel like rubber, doesn't it?
Mine's soil.
Yours has got dirty. But yeah, they've got this sticky kind of feeling to them. And that's because they've been made in the same way, with the same structure as gecko's feet. So do you want to have a look around again at the microscopic images and see if you can find the microscope image that matches up with these? No, those have got little hooks on them. We can talk about those in a minute. There's something else. Yeah, well done. So these kind of long bits, it's the forces that these create that make it have that sticky feeling. So sometimes when you feel sticky things maybe in your house, it might be something that's a little bit dirty or it's a liquid, but this is to do with its actual structure that makes it sticky. So this will forever be sticky. No matter how long you have it for, it's still going to retain that structure that makes it sticky. So that's another way that we can take inspiration from nature to make something that we can use in our homes. Can you think of any ideas of how you could use this sticky material? Yeah, if you wanted a non-permanent glue, so someone had a good idea that you could stick it on your wall in your kitchen, and then if you'd done a drawing, you could stick it onto there and it would stay up, maybe and then you could just take, that's a really good point, like a fridge magnet, yeah, you could use it like that. And then you could just take it off whenever you wanted and put something else up. So that's a sticky property that comes again from the structure. So the same way with the lotus leaf, the important thing was the structure of the material that gave it its property. It's very unusual to get this bright blue in nature. It is possible, and some people over there are talking about it, but it's a very uncommon colour in nature. So this is actually a man-made object that we've taken inspiration from nature. Can you find the object on the table where we might have taken inspiration from it? That's it itself, that's just more of it. So what's this here? Soil. But is it similar to the soil outside?
No, when it gets wet, it's still soil. And then turn into mud.
That's true. So outside, the soil out there gets really muddy when it turns wet, whereas this soil is being hydrophobic. It's repelling the water again.
Unless you put your finger literally.
You get into the water, yeah. So these two are similar to each other, but in a different way from the lotus leaf.
They're pretty much the same, because that's a different colour and it's man-made.
Yeah, exactly. And this is almost better at it, wouldn't you say? Like this is like doing a better job than the soil.
If you put water on it like a tiny drop, would it just stay down? That's still there. I might try that. Yeah.
Yeah, it's amazing, isn't it? So we've seen the lotus leaf is hydrophobic, haven't we? Repels water. We've also seen the sand is hydrophobic, but they're hydrophobic for quite different reasons. So the lotus leaf, it was to do with its structure, whereas with the sand, it's actually covered in like a thin waxy layer, and it's that waxy layer that repels the water from it.
Oh yeah, if you separate it out, you can kind of see on the edges.
Yeah, yeah.
Wait, what's this?
Do you know what this is? Try and pull it apart.
Oh, it's a Velcro.
It is Velcro, like you've got on your jacket. Did you know that Velcro was made by an inspiration from nature? Yeah. So you use the magnifying glass to look at the Velcro and also to look at the... And tell me what's similar about them. Yeah, they've got these little kind of hairy hooks, don't they?
Yeah.
It's that hook.
Like that.
Exactly like that. So do you wanna, so this is another thing from nature, a bit of wool. Do you wanna try and pick up bits of those with it? Like using this, like a fishing rod, yeah. Yeah. So look how well that gets stuck. Can you see how that's the same?
Wait, isn't that on the back? That?
Yeah, kind of, isn't it? You're right, it is, isn't it?
It's yeah.
It's like a sticky thing, so it's like both of them at the same time. So yeah, can you see how these match together? Which one does this match with? That, and then what about this one? But this, I mean this side to it, yeah. Yeah. So this is how they could see something in nature and then go away and make the same thing for man-made materials to use. And now everyone uses it on their jackets, on their shoes, loads of things.